Operations on radical expressions. Let's perform the indicated operations and simplify. Example 1. Here is given 3 times the square root of 20 minus the square root of 5 minus 3 the square root of 45. So we have to perform the indicated operation, means that if we have some radicals and we can simplify them, yes, we can do it. And then if we have similar terms, we can combine. Now, how we combine similar terms? Let's recall as we combined like terms. For example, 3x plus 2s is 5x because we work with coefficient, and then we associate the common variable. Like terms were the variable part was exactly the same. Similar terms are terms that contains radicals, and the radical part must be exactly the same. And in the same way we work 3 plus 2, 5 square root of 2's. As here was x, common variable. Now, 20 is not a perfect square number, so I can write 20 as a product of 4 times 5. Also, 45 is not a perfect square number, but I can add 45 as 9 times 5. And then I will separate them. Now let me bring down what I have here. I have 3 negative square root of 5 minus 3. Okay, and now I'm going to multiply 3 times 2, the square root of 4 is 2, minus 3 times 3, the square root of 9 is 3. This is the reason that I wrote 20 and 45 as a product of a perfect square factor and another factor. And now clearly I see that I have similar terms. All of them contains the same radical part, which is the square root of 5. And now how many square root of 5's I have? How many x's I had here? So here I have 1. And let me see how many I have. I have 3 times 2, 6, minus 1, minus 9. All of them square root of 5's. So I have 6 minus 1, 5, and positive 5 and negative 9 is negative 4. Done. Example 2. I have the cube root of 3 plus 2 times the cube root of 24 minus 6 times the cube root of 81. Still, 24 and 81 are not cube roots, but we can separate them, as here I will write 8 times 3. I can write 24, 12 times 2, or 6 times 4, but none of them is a perfect square factor. So let's factor 24 as 8 times 3 and 81 as 27 times 3. Then we'll go and separate, don't forget the cube root. The cube root of 8 times the cube root of 3. And this is the cube root of 27 times the cube root of 3. And let me bring down what I have. I have negative 6 here, positive 2 here, and let me write the cube root of 3. Okay, let me go. The cube root of 3 plus 2 times the cube root of 8 is 2, because 2 to the third is 8. The cube root of 3 minus 6 times the cube root of 27 is 3, because 3 to the third is 27. And now I see that I have similar terms. All of them contains the same variable part, which is the cube root of 3. How many cube root of 3's I have? I have 1 here, plus 4 here, and negative 18 here. All of them are cube root of 3. So I have positive 5 and negative 18 is negative 13, the cube root of 3. Done. Example 3. I have a binomial 2 minus the square root of 7 squared, which means to multiply the base, which is a binomial, twice. Or you can use the binomial formula. Let me write it here. The binomial formula a minus b squared is equal to a squared minus twice a times b plus b squared. You can use this. Let me go and multiply. 2 times 2 is 4. 2 times 7 cannot be, because 7 is a radical and 2 is not, so I will write minus 2 times the square root of 7. And now I'm going to multiply negative square root of 7 with 2. Still I cannot multiply. I write negative here, 2 here, and then the radical. And when I'm going to multiply negative square root of 7 with negative square root of 7, I have a positive product, and this is the square root of 49. You can leave this as the square root of 7, because both of them are the same. They will produce us 7. Okay, they will give us 7. So if you want to leave like that or multiply, it doesn't matter. So what I have else, I have to combine those two. So I have 4 minus 2, and 2 is 4, square root of 7. In other words, I'm combining two negative terms, negative 2 and negative 2, which is addition, so I have similar terms here. Combine them together. And the final answer is 4 plus 7, 11, minus 4, square root of 7. Example 4. I have negative 4 square root of 2 times a binomial, which is 2, times square root of 5 minus 3 square root of 6. So what I'm going to do here, I'm going to multiply the term that is outside with the quantity. So what I have, negative 4 times 2 is negative 8. 2 and 5 can be multiplied because they are under the same radical. So let's recall, again, when we multiply, we need the indexes. So 2 times 5 is 10, the square root of 10. Negative 4 times negative 3 is positive 12. And 2 times 6 is 12. As we see, those radical parts are not exactly the same. This is 10, and this is 12. So I cannot do nothing, but I cannot combine them, but I can break 12 as 4 times 3. So let me break this. And now I have 12 times 2 square root of 3. And I have 24 square root of 3. Let me bring down negative 8. I didn't touch it because I couldn't do nothing here. So what I did here is that I wrote 12 as 4 times 3 and then separate it. Example 5. So I have 2 square root of 6 plus 3 square root of 5 times the square root of 8 minus 3 square root of 12. So I am multiplying two quantities here. Is almost the same as the work that we did on example 4. Here we had only one term in front of the second of this quantity, and now in front of this quantity, which is a binomial, we have two terms. So we have to work once for that to multiply the second quantity and then for the second term. So let's go. So let's go and multiply by the first term. 2 times 1 is 2. 6 times 8 is 48 under the square root. 2 times negative 3 is negative 6. 6 times 12 is 72. Now let's go start with the second term. 3 times 1 is 3. 5 times 8 is 40. 3 times negative 3 is negative 9, and 5 times 12 is 60. So what we did here, we multiply integers by integers and the radicands by radicands. All of them were square root, so we are okay. Now let's simplify. Can we simplify 48? Yes. 48 is 16 times 3. 72 is 36 times 2. 40 is 10 times 4. And 60 is 10 times 6, but 6 is not perfect square number as 4 was, so I have to, the only thing that I can do, this is divisible by 4, the only perfect square number that is inside 60, which is 4 times 15. So in other words, if you write 60 as 6 times 10, then break it down in 3 times 2, 10 is 2 times 5, so what we have here, we have 2 times 2, 4, and 3 times 5, 15. Okay? And let me go and separate. Why I wrote 48, 16 times 3? Because it's a perfect square number, the largest one, the largest perfect square number, the largest, and so on. So, let me separate 16, 3, 36, 2, 4, 10, 4, 15. Okay, and now let me bring what I have here. I have 2, I have negative 6, and I have positive 3. Okay, so I have 2 times 4. The square root of 16 is 4 times the square root of 3 minus 6 times 6, the square root of 36 is 6, plus 3 times 2 minus 9 times 2. As I see, no similar terms here, the radicands are different. Even though I have square roots, the radicands are different. So I cannot simplify. The last thing that I have to do just to multiply and I'm done. 8 square root of 3 minus 36 square root of 2 plus 6 square root of 10 minus 18 square root of 15 and done. Example 6. I have the square root of 12 over 4 plus the square root of 27 over 6. Be careful, 12 and 4 are divisible by 4, but do not simplify because 12 is a radicand and 4 is not. 27 and 6 also are divisible by 3, but we cannot simplify. 27 is under the square root and 6 is not. So be careful. The only thing I have to simplify, 12, yes I can, 4 times 3 over 4. Do not simplify, be careful. 27, 9 times 3. Do not simplify, so separate. And now I have 2 square root of 3 over 4 plus 3 square root of 3 over 6. I can divide here both up and down by 2 and here by 3. So here I have 1, here I have 2, and here I have 1, and here I have 2. So 2 divided by 2 is 1, 4 divided by 2 is 2, 3 divided by 3 is 1, 6 divided by 3 is 2, or you can go 4 divided by 2 is 2, but be careful to write 2 underneath. So what I have 1/2 square root of 3 plus 1/2 square root of 3. Let me write it again here. Okay, which is the square root of 3. So let me rewrite here because sometimes camera doesn't take it. So I have 1/2 square root of 3 plus 1/2 square root of 3, which is 1 square root of 3. Done. Example 7. The square root of 18 divided by the square root of 16. Now, in this example, we have radicals on the denominator which we don't like. We like the denominator to be free from the radical. But in this case, we are lucky because 16 is a perfect square number and the square root of 16 is 4. So this is okay. And now 18 can be written as 9 times 2. Separate, which is 3 times the square root of 2 over 4. Do not simplify. Example 8. I have the cube root of 27 over 64. So this is telling us that we have a cube root and the radicand is a fraction. So we can separate this radical into two radicals, one for the numerator and the other for the denominator. So the cube root of the numerator, 27, the cube root of the denominator, 64. Okay, so the cube root of 27 is 3, the cube root of 64 is 4. Or you can work like this directly. The cube root of the numerator is 3, the cube root of the denominator is 4. Example 9. I have 4 times the square root of 12 over the square root of 5. Now here we have a problem. We have a square root on the denominator, but 5 is not a perfect square number, so we have to think how to destroy the denominator from the radical part. So how to free the denominator from the radical? And we call this rationalizing the denominator. This is happening in only way if I multiply the square root of 5 by itself, which will give me the square root of 5 squared, and this is just 5. Okay? We know this. Now, let me write also, I have to multiply on the top by the same thing. And now I am separating 12 as 4 times 3. Okay, so I have 4 times 2, and 3 times 5 is 15 over 5, which is 8 times the square root of 15 over 5. So again, do not simplify. Example 10, and the last one. So we have the square root of 7 over 3 times the square root of 2 minus 5. Still, I have a radical on the denominator. I have to rationalize the denominator. That means to free the denominator from the square root. And I know how to do this. If I square the first term here, the radical will go. In other words, what is my plan? I want to square this, and then 2 will be free, no more radical. But I have to square now and 5 to have a difference of the square. Okay? In other words, this is what I want. If I want to square this, and I have I need to square the other in order to have a difference of the squares. Now, this is what I want. Let me rewrite this again. How to obtain the difference of the square? Only if I multiply by exactly and with a plus. So 3 square root of 2 plus 5. And I know that this will produce me what I want. Okay? In other words, I have a minus, I will write everything but with a plus. If I have a plus, I will write with a minus. We know how the difference of the square works, so we never forget to multiply up and down by exactly the same thing. So this is not plus, it's not our case. Okay? And now, when I work, I know what I'm expecting. On the denominator, I'm expecting the difference of the squares. So the first squared minus the second square. And on the top, I'm going to multiply. And when I multiply by a radical, okay, I know that I will multiply only radicands that are inside the square root in this case. So 7 times 2 is 14. Under the square root, don't forget to write 3. 7 and 5 cannot be multiplied, just write plus 5 times the square root of 7. And now let me work on the denominator, because on the numerator I cannot do nothing, they are not similar terms. So I'm done with the numerator, and the denominator will give me what? The denominator will give me 3 square, 9. The square root of 2 square is 2. Minus 5 square, 25. And this is 18 minus 25, so the denominator becomes negative 7. Okay? So I have 3 times the square root of 14 plus 5 times the square root of 7 over negative 7. I can multiply up and down by negative 1, which means just change the signs, because we don't like to leave the denominator with a negative sign. So, and since this quantity is positive, why to go and multiply and make them negative? I will just leave the negative sign in front of the fraction bar, and I'm done. So this will be positive 7 as I wanted. The last step. Thank you. This was the first part of this homework 7. The second part will be on another video, when I will discuss how to solve equation that contains radical expressions. Thank you.